Good morning. Welcome to the lecture 8 of this ongoing course on orthographic projections or architectural graphics. So, in this particular lecture, we are going to learn about scales. Now, what is a scale and why is it so important for drawings? So, scale is basically required to literally scale up or down a particular drawing and draw it on a given size of sheet. So, for example, as I had said earlier also, if you have to draw the drawing of this huge room, so how would you fit the drawing of a room on a small sheet? You could draw on a very small piece of paper, an A4 size sheet, an A3 size sheet, or maybe an A1 or an A0 size sheet. It could be any sheet. Now, how would you draw that? And all the drawings drawn on different sheets, however big or small they may be, should be able to represent the same dimensions which we want them to read. So, for example, this hall where I am standing currently is approximately say 5 meters by 15 meters. Now, 5 meter by 15 meter in a true scale is not possible to be drawn on a sheet, nor is it required. So, if I will draw it in such a manner that every centimeter, 1 centimeter is equal to 1 meter. So, what does it mean? 1 centimeter is equal to 100 centimeters, 1 is 200. So, that is a scale on which if I draw this room which was 5 meter by 15 meter would be drawn as 5 centimeter by 15 centimeter. Very simple. This is a type of scale which we use to draw a bigger object, a bigger thing on a smaller sheet of paper. It could be the other way around. For example, I am drawing an engineering machinery part which is a very small tiny part, and I want to make it in such a manner that I am able to show the very fine details. So, maybe that it is a very small screw which goes into a machine and it is just 1 centimeter by say 0.5 centimeters of a screw, and then there are all those wiring on that, there is a detail on the end and on the top, and there are a lot of these things. So, what I will do? I will draw that 1 centimeter of that screw at an enlarged, a bigger scale, and I will see this 1 centimeter being represented as 10 centimeters, so that I can show all these details on it. There the scale is 10:1. So, 10 centimeter of an object represented on the sheet is actually equivalent to 1 centimeter of the real object. That is also a scale. So, we could scale up, we could scale down, or we could also draw on a true scale. For example, the section of a door frame. So, it could be exactly the same size and will be drawn at the same scale in the drawing. That is a true scale. So, the first thing that we need to learn about this is what are the different types of scales. Reducing scales, as I said, are used when the object is much bigger. For example, somebody is designing a bridge. Now, that is a huge bridge. We cannot possibly draw it on the sheet of paper. So, we will have to reduce its scale. So, these are called reducing scales where the real object is much bigger than what is shown in the drawing. So, any scale where we have 1:50, 1:100, there could be any scale for that matter, 1:200, 1:250, 1:500, all these scales where 1 unit represents a larger, bigger number unit, that is a reducing scale. So, here the real object will be much bigger than what will be represented on the sheet. Now, the other one, the second one, where the object is, the real object is much smaller and what is shown on the sheet is much bigger version of it, that is called an enlarging scale. In this, you will write say 10:1. So 10 units represented on the sheet are actually representing just 1 unit of the real object. 10 is to 1, 50 is to 1, 25 is to 1. It could be any, depending upon. Now, how do you decide that what is the scale to be followed? Usually there are some standard scales. So, the ones that I have written are usually the common ones used, they are the standard ones. But you choose a scale depending upon the size of the drawing to be represented, size of the object to be represented. For example, you have a huge site. So, for example, there is a city plan being drawn. Now, you also need to put it on a scale, it has to be proportionate, but then it has to be reduced. Now, how would that be reduced? So, depending upon the size of the sheet on which it has to be printed. So, for example, the city plan, sometimes if you go to cities, you find transportation plans where the road network would be shown, or maybe the broad districts are shown, or something like that. So, depending upon the sheet of paper, it could be an A4 sheet, which is a handout, it could be a bigger sheet, or sometimes it is even bigger than A0s. So, maybe 4 A0s together put up one city plan. So, depending upon that, the scale could be very odd. 1 is to 5750, just to fit that entire drawing onto this sheet, that entire city plan onto this sheet. So, depending upon the size of the sheet, these scales could also vary. You could choose some scales which are not standard ones, which are not commonly used, but still they will serve the purpose and that is desired at that moment. So, these scales are chosen depending upon the real size of the object and the sheet on which they have to be represented. The last one, which is full sized scale, is 1:1. So, when the real size of the object is drawn on the sheet, it is called a full size scale, 1:1. So, if it is like 10 centimeters big object, it will be drawn exactly as a 10 centimeters on the sheet. That is what the full size scale is. Now, these different types of scales could be represented on sheet in multiple various ways. That is what we are going to learn in this lecture. So, whenever you are drawing, writing, mentioning the scale or drawing a scale is mandatory. We have to draw the scale and it could be done in multiple ways. The first one, which is very simple and which is often used, it is called the engineer's scale. And how do we do that? Just as I had done in the previous slide. So, what do? We just do one, we just write 1:100. That is the scale. So, it implies that 1 unit is equal to 100 units. I do not write what unit is it. Depending upon what unit are you going to use, it will be. So, 1 centimeter is equal to 100 centimeter. 1 meter is equal to 100 meter. Anything. So, any unit you pick up here will be equal to 100 units of the same object in reality. So, it means that a 100-meter long road will be represented as a 1 meter long road here. 1:100 is not that reduced a scale. If you look at the map of India, sometime you could actually be seeing it at 1:50,000, 1:5 lakh, depending upon at what. So, whenever you see the map of India, whether it is, you might have definitely used the map of India for your geography classes in school. So, the small sized map is also very proportionate. You look at it and you say, this is the map of my country. Why? Because it is proportionate. It is just that it is scaled down. It has been reduced by using a reducing scale. So, the scale there, the number will be much bigger. So, 1 is to say 1 lakh, 1 is to 5 lakh. They do not mention, it is just proportionate, but if you really look at that, there must be a scale. Now, the purpose there is not to actually measure the dimension, it is just to know relatively that okay, where this river is or where that city is. So, you tentatively draw that, but if we are to measure the distances, so in all the geographical maps, whatever you find, wherever, you will always find a scale in the bottom somewhere. Now, it could be written, represented as an engineer scale, which is just simply written as a number, or the second one is graphical scale. Now, this is something that we usually use. Now, graphical scale is where you draw that this particular unit, this unit, it could be 1 centimeter, 1 inch, this unit is equal to how many units. So, that is what we would write. So, if it is 0, maybe there are say 4. So, if we write it like that, we would write this is 4 meters. Okay. So, instead of reading it as how many units actually drawn here are equivalent to 4 meters, we just draw it that this is equal to 4 meters. Now, what is this and how will we read it? So, to read it, we will just measure, we will take a divider, we will just measure how much is this and measure the same thing on the drawing that is represented on the sheet. So, you measure that drawing and you put it on the scale and you will know that how many units are being represented here. That is what this graphical scale does. Now, why at all do we need a graphical scale? Why couldn't we just do with engineer scale? We could just write, and most often, by the way, we write, especially because we are now making the drawings on computers. So, what happens that digitally you anyways have that drawing which you draw in full size scale, and then while printing you just reduce or enlarge it and it could be reproduced very easily, but it was not the same in the old times. So, how were the drawings being made? They were being made by hand. We were drawing it by hand. So, when you were drawing it by hand and then the paper would shrink, sometimes they were on the piece of cloth. So, it would shrink during the winters and then sometimes it would expand. So, instead of just writing, now if suppose we had written that okay, this country's map is drawn at the scale of 1:50,000, and then somebody just went on to measure that okay, how much is the overall area of this country, he or she would get a different result every time, because the actual thing, the actual dimension which we were measuring on the sheet would vary in different seasons over the years and all that. So, to avoid that, they would draw a graphical scale like this on the same sheet of paper. So, if the paper would shrink, this entire scale would shrink simultaneously along. So, whatever this distance is, of course, initially there would be a proper scale which would have been used, but whatever this unit is would remain the same and it would still mean 1 meter. So, the paper has shrunk, this unit, this particular distance has also shrunk simultaneously, and that is how the graphical scales are actually used to look at it, to measure it by using a tool and then read the dimension. That is what the intent of using a graphical scale is. Now, whether we are using an engineer scale or a graphical scale, but more for graphical scale, one thing which we need to know is RF or representative fraction. So, it is called representative fraction and we very commonly use this term as RF. Now, what is RF? RF is equal to the length of the drawing upon the actual length of the object. So, if I say that the length of the drawing is 1 centimeter and the actual length of the drawing is say 10 meters. So, that is 1000 centimeters, same units we have to keep. So, the representative fraction is 1:1000, which is how we represent this scale. So, this is the way of representing this RF, this representative fraction. So, this engineered scale is a way of representing this RF representative fraction, which is say 1:100 here, and the RF here would be defined, it would be determined, and it would just be represented as a graphical scale here. So, that is what the purpose is. Now, what we are going to learn about is how to draw the graphical scales. There are various different types of graphical scales which are used. We are going to learn about 2 scales here. I am showing it to you here on screen, and after that we would quickly look at how to draw them. So, this is a plane scale, the first one is a plane scale, and what we do here is that we would simply draw a simple scale, a straight scale. We would divide it into some equal number of units, sufficient enough to measure the maximum dimension on this drawing, whatever drawing is given. So, that is what we would use. So, this is say RF 1:4, this is in decimeters, and here we measure centimeters. So, the last unit, so the 0, as you might have realized, observed in the previous slide also, we always start 0 at 1 unit from the left hand corner and then have equal number. So, these are all equal. So, these are equally spaced lines. So, say 4 units this side and 1 unit this side. Instead of writing 1 here, we have written 10, which is the 10th division of this bigger unit. It could also be 100, it could be, so depending upon, suppose if it was meter and we were representing centimeters here. So, then we would have, this would have been 100 here. So, while it is 1 meter here, this is actually 100 centimeters here, and instead of 0 we would have had 5, we would have had 50. And what we would do? We would divide this last one into equal number of divisions depending upon what is the scale. Suppose we are using inches and feet. So, in that case we would have divided it into 8 equal parts, but since mostly we are using the metric system, and I am also demonstrating this entire process for metric system, we would most often divide it into 10 equal parts, and each part is equal to 1/10 of the unit being represented here. So, if it is meters here, this one is equal to 10 centimeters. If it was decimeters, we would have measured 1 centimeter here at whatever scale we would have drawn. So, that is what this simple plane scale is. It is easy to draw. The only thing that we have to do is divide this 1 unit representation into 10 equal parts. We have already seen how to divide any given line into equal number of parts. So, that is simple, that is very easy, we can simply do it. So, that is what the plane scale is, and we always mention the reference representative fraction. The second one is a diagonal scale. Now, in this one, if you had to measure, I would say, suppose we are considering meters and centimeters here. If I say that we have to measure 1.5 meters, it was easy. We would measure 1 here and 0.5 here, and so this distance would be equal to 1.5 meters here, 1.5, 1.1, 2, 3, 4 like that. Now, what if I say that I have to measure 1.37 meters? How do we do that? It is not possible. So, to take it to the second decimal, we would use this diagonal scale. It is much easier. So, what we do here is, for the first line 0 to say, so this is a 10 centimeter line or 10 units line, and it represents 100 meters, right. So, each one represents 100 meters, 100 units. In the last one, what we do, we further divide it into 10 parts as we have done for the plane scale, But in addition to that, we also raise a scale vertically. Okay. So, we raise the scale vertically, we divide it into 10 equal parts, and then we join the first fraction here to the first fraction here. Now, as this triangle goes on increasing, we can see that the horizontal distance here is 1/10 of this unit. So, suppose just like in the previous example, if we were counting meters here and we are taking say centimeters here, we can then go to the second decimal place. We can now measure 1.37. So, how do we do that? Say 1 here, 3 units here. So, this is 1, 2, 3 units, and I move it up to say 7. So, this point is 37. This is what this distance is. So, here as it has shown 653 meters. So, this is 650, and then we take it to the third one. So, this has already increased from here as 6.50 to or 650 to 653 at this point. That is what this diagonal scale enables us to do. So, we can actually measure it up to the second decimal place, or we can actually measure it like this. This is what diagonal scale enables us to do. So, in any drawing, in reality, we always do not get the simple fractions that okay, it will be 650, it does not jump like that. It could be 653, 657, 651, whatever, it could be anything, and that is what is measured using this diagonal scale. So, let us now move on to the sheet and we will see how to draw both these scales, both the plane scale and the diagonal scale. And every time you draw your sheets, you have to mention both an engineer scale as well as using graphic scale, depending upon what kind of scale do you require. If it is a simple drawing, you can do with plane scale, you can go ahead with that. If not, you have to draw the diagonal scale. So, let us shift to this sheet and see how to draw these scales. So, now we are drawing the scales, both types of graphic scales, not the engineer scale of course. So, we are drawing the scale onto the sheet. Let us see how do we do that. So, suppose I am drawing a 1:500, a scale to represent this RF of 1:500. Now, if I have to draw a scale big enough to measure say 50 centimeter. So, 1:1/500 into 50, that will give me 0.1 meter. This is meters here. So, it means that I have to draw a scale up of 10 centimeter. If I have to measure a maximum dimension of 50 meters on an RF of 1:500, I will have to draw a line of a scale of 10 centimeters. That is what we are going to do right now. So, 10 centimeters. So, here we measure 10 centimeters. Now, this one we will divide in 10 equal parts. So, I have already divided this line into 10 equal parts, but the very first division we will have to divide into 10 equal parts. So, to make those 10 divisions, I again draw a line at an acute angle, and I am again taking here a 10 centimeter line. It could be anything, but just for the convenience so that I could mark it here, I have drawn another line, acute line here with 10 divisions on it, and now I will connect it. So, now the first unit has to be divided, the first division has to be divided into 10 equal parts using the same division of line rule. So, what I have done, I have drawn an acute line at a line at an acute angle from this given line, and then I have drawn 10 marks, 10 equal divisions on that, and now I am connecting the last of the mark with this point, and we will just draw parallel lines from these points coming on to this division, the first division. Now, if you see here, we have already achieved the 10 divisions onto this of this first division, each one measuring equal to 1 mm or 1/10 of the centimeter. But what we were taking here is that this is a scale, the representative fraction is 1:500 here, and we are representing a line of 50 meters here. So, when we are writing, when we draw, so 1 centimeter here is equal to 5 meters. That is what we are representing, and if we start to draw like this, and this one becomes a 0, this is the division. So, what we have here is 0, and then we can start writing 5, 10, 15, because each unit is 5 meters. So, this is equal to 45 meters here, and on this side this is 5 meters, or we could also write 500 centimeters. So, we could also write 500 centimeter here, and this side it is meters. This is a scale, and then for each division we could also mark these lines, or we could just mark the middle one, which is 250 centimeters, or we could also write the divisions in between depending upon what is the common unit, the dimension to be measured. This is a plane scale representing an RF of 1:500. That is what this particular plane scale represents. Now, the next one is a diagonal scale. So, with the help of this one, you can actually measure a distance, a dimension which is the minimum unit of that, the minimum fraction that we can measure from that is 1/10 of 500 centimeters, that is 50 centimeter. So, we can measure say 5.5, we can measure 2.5, because each fraction of this first division measures equal to 50 centimeter or 0.5 meters. We cannot measure anything lesser than this 0.5 meters or 50 centimeters. Now, if we want to measure a dimension of say 267 centimeters, okay. So, which means we want to measure 2.67 meters, right, or we could also make it bigger, because here we can measure all the way up to 45 meters. So, we could measure 25 meters here, 25.53 meters. So, suppose we want to measure 26.7 meters say, then how do we measure? So, we will draw a diagonal scale to measure this 26.7. So, while drawing and say the representative fraction now is different. Suppose let us take this our f to be of 1:200, and we are going to be measuring 26.7 meters. The maximum that we want to measure is 50 meters. So, for a given RF of 1:200, how much do we need to draw is 1:200 into 50. So, this is 1/4 meters, that means 25 centimeters, 0.25 meters, 25 centimeter. So, for a given RF of 1:200 where we want to measure 50 meters, we will be drawing a line of 25 centimeters. So, let us draw this diagonal scale here. So, we have taken 25 centimeters and we want to divide. So, what we want to take again is we want to measure up to 50, and we can divide it into 10 equal parts, where if we divide it into 10 equal parts, each part will be measuring 2.5 centimeters, and that will be equivalent to 5 meters. So, let us do that. So, we make these equal divisions of 2.5 centimeter each, and now what we have to do is, we could have drawn it using the division of line method, but since it is a simple unit and we could have divided using a scale, that is what I have done. And now what we have to do is, we have to divide this first division into 10 equal parts, and we will do it using the same method as we use. So, I am again dividing this line into 10 equal parts. And we will have these 10 divisions, equal divisions, by drawing the parallel lines. So, we now have these 10 divisions in the first fraction onto this diagonal scale. Now, what we are required to do after this is, we have to draw further 10 divisions. Now, it could be any size of the line there. It does not need to be 1 centimeter each or whatever, but just for ease we may take it to be a simple division. So, I am taking 0.5 centimeter here, and we will again draw parallel lines. Again, you draw vertical parallel lines at each of this fraction. So, what we have here is, this is 0, this is 0, and each 2.5 centimeter division is equivalent to 5 meters. So, we write it here 5, 10, 15, 20, 25, 30, 35, 40 and 45. This is meters, and RF here is 1:200, that is what we are drawing. Now, this side we have again 5 meters, but we will represent it as 500 centimeters here, right. And now, let us again take these 10 divisions in very light lines vertically up. So, we have again taken these 10 equal parts up, and what we are going to do here is, we are going to join the first part here with the top first line. That is how we draw, and we fix up this angle, and then we draw these 10 equal parts. That is what the diagonal scale is. So, what we now have to measure is, say, 26.7 meters, right. So, we have 25 meters here. So, just look at it carefully. 25 meters here. Now, what we have to do, or we could take 20, right. This is 500 centimeters. What we have to do, so each division, this is 10 divisions here, this is 50, 250. Now, if I divide, this is 50 each. So, if I take, this is 50 centimeters, right. So, it is 0.5 meters. I am here at 20, 25 meters, 25.5, right, 25.5, 26, 26.5. Now, I have to measure a 0.2 here. So, I take it at here. This is 26.7. So, that is how we will measure. So, simply we will just measure the distance here from here, and that is what we are going to get. This is how we are going to measure any given distance, but then it depends upon how we draw this scale. This is for an RF of 1:200, and this scale is capable of measuring up to 50 meters. So, this is how we are going to draw a diagonal scale for any given RF and to measure a given distance. I hope you are able to understand the concept of scales and how we draw these scales on sheet and why we draw it. From the next lecture onwards, we will start to understand the different basic shapes that are going to be used, solids as well as two-dimensional shapes that are going to be used in our graphics course. So, thank you for being with me here today. Let us see you in the lecture 9 tomorrow. Thank you.